Hello everyone, welcome in Finite Element class. So in this video I'm going to show you or explain about the isoparametric elements. Isoparametric I will use for this topic Lagrange method. Actually I will not explain. You can go to any references to get some knowledge and the basic, but here I'm show you how we can check criteria and check chain functions for this element by Lagrange method. So here in this video I have some examples. One example, like the first one, I have one element, and second one I have two elements, and the other point I have more than two elements. So let's start. Here in this one, for A, I have one element. The length of this element is 12. Okay, and the original, it's actually 1D, as you see, because we have in this topic 1D, 2D and 3D, but let's start with 1D first. So in this question number 1, I have one element, 1D element, and I have two nodes for this element. Node number 1 is xi or zeta equal -6, and node number 2 or zeta 2 equal 6. Okay, so I want to find the n of node number 1. How can I write it? Zeta, this is actually the rule of Lagrange method. It looks like a series. Okay, so xi minus xi 2 over xi 1 minus xi 2. Okay, here xi, it's unknown, and xi 2 is 6. Here, this one is, I hope it's clear for you. This one is xi 2, just substitute here 6. Xi 1 minus 6 minus 6 for xi 2. After that, I got this equation. After substitute my values and make it as simple. So node number 2, xi minus xi 1 over xi 2 minus xi 1. So here, if you want to work on node number 1, for example, as I'm working here on node number 1, you should neglect the xi of node number 1. And also, if I work on node number 2, neglect xi number 1. Okay, and below, this is for top, and for below item, start with the node of that for that node that you are working on. You will see in the next example. So here we have only two nodes because I have one element. So my rule, it will be this one, the Lagrange method. After that, check criteria. Check criteria, the first one should be after you substitute the value of z1. I'm working now in node number 1. The z1 is minus 6. Just substitute there in the xi. You will get 1. This is okay. For the node number 2, also substitute the xi of node number 2. Number 2 we have positive 6, so I put positive 6. I get 0. It's okay, no problem, accepted, but the rule should be 1. Second point is summation of nodes equal 1. That means I will do here, in this example, I have node number 1 plus node number 2. I don't have other nodes. So substitute here each value of each node. That means this one is for node number 1 and this is for node number 2. For node number 1, I substitute here minus 6 and here we have 6. So I got 1. That's okay. Criteria number 3, derivation. You should derive n1 and n2. Summation of these derivations, you get 0. So here the n1, I just have it's from 1 degree, equation of 1 degree. I have just zeta. Zeta in derivation is already go 0, nothing. So I just have 1 over 12. Okay, and for the node number 2, same, only 1 over 12. So summation will be 0. This is actually just basic of how you can solve the Lagrange method on if you have 1D, 1D, and if you have one element or more than one element. Second one, question number B. I have here two elements. The first element start from node number 1 to node number 2. Number 2 here is 0, the original points. Okay, and node number 2, this is node number 1. Elements, I'm sorry, element number 1 and element number 2. Here node number 1, node number 2, and node number 3. Okay, so Lagrange method for the node number 1, zeta minus, look, I neglect node zeta 1 because I'm working on node number 1. So my rule is n1 equal zeta minus zeta 2 time zeta minus zeta 3. 3 for node number 3 and this is for node number 2. I don't have one more to put it zeta minus zeta 4. Okay, go to the down. I'm working on number 1, so zeta 1 minus zeta 2 and zeta 1, time zeta 1, second item, zeta 1 minus zeta 3. Okay, substitute your values, you will get this one, zeta 2 equal 0, okay, zeta 3 equal 6, okay, zeta 1 minus 6, zeta 2 0, zeta 1 minus 6, and zeta 3 6. It's easy, it's very easy, just is easy because I'm working on Lagrange method. Okay, second node, okay, I have this one. Actually, after I time minus with multiplied, I got the n1 like this one, or this is the equation of node number 1. Go to second one. Second one, zeta minus zeta 1 time zeta minus zeta number 3. I neglect node number 2 because I am working on node number 2. Go down, zeta number 2, okay? It's not like sequence one by one. Just start with the point that you are working. Zeta 2 minus zeta 1, I go to previous, and then continue to the others point. So here actually you can write zeta 2 minus zeta 2, but it will get 0, so that it should be neglect, it just because no value, empty. Okay, so zeta 2 minus zeta 3, zeta 1 equal minus 6, zeta, let me to be clear, okay, so zeta 1 minus 6, it will be positive 6 here, at zeta minus zeta 3, zeta 3 is 6, okay, this is 1 6, zeta 2 is 0 plus, or sorry, minus zeta 1, zeta 1 is minus 6, minus with minus, you will get positive 6, and for zeta number 3 is 6 here. After you make it a make it simple for this, I will get n2. Same way with node number 3. So I already given the value of node number 3, but just to write for you, node number 3 equal zeta minus zeta 3, okay, sorry, I'm sorry, working on zeta, sorry, zeta 1, I'm very sorry, I have mistake, zeta 1, zeta minus zeta 2 over zeta 3 minus zeta 1 and zeta 3 minus zeta 2. Okay, this is for node number 3. After that, just check criteria. The first one should be get 1. I mean, take the node number 1 and substitute the value of number 1, and you will get 1 here. And same with node number 2. Node number 2, the zeta 2 is 0. Just substitute 0 in the node number 1. That means you should take the node, I'm working on node number 1. You should try to substitute all values of zeta. Zeta 1, zeta 2, zeta 3. Here we have 3 values of zeta. so just substitute in the node number 1. Same, okay, I didn't do for the node number, for the others node. Okay, no problem. Sorry, oh, actually, sorry, I have a mistake, I'm very sorry. So just substitute the value for the node number 1, here -6, just substitute in the node number 1, and for zeta 2, 0 is just substitute in the node number 1, and so on. Okay, after that, some ticket summation of all nodes. Here we have n1, n2, and n3, and substitute the value. Zeta 1 we have, sorry, for node number 1, zeta is -6, substitute -6 in each zeta, and for the node number 2 is 0, zeta equals 0, and here for node number 3 substitute the value of zeta is 6, you will get 1, so that's okay. And after the last point is derivation, summation of derivation of each node. Just derive each node and substitute the values of each node in on n, or in on nodes, the value of zeta, I mean, you will get 0, that's okay. So let's go to question number 6, C. In the question number C, I have 3 elements. So here element number 1, element number 2, and element number 3. Okay, so that I'm going to find the n1. n1 equal zeta minus zeta 2 time zeta minus zeta 3 and zeta minus zeta 4. The down rule, zeta 1 minus zeta 2, zeta 1 minus zeta 3, and zeta 1 minus zeta 4. After that, substitute your values of zeta for each node. So see it here, zeta 2 I have -2, it will be positive 2. Zeta 3 is 2, okay. Zeta 4 is 6, okay. I substitute or put it in its place. Sorry, zeta 1 equal -6, zeta 2, zeta 2 is -2, it will be positive 2, and zeta 1 is -6, zeta 3 is 2, zeta 1 -6, and zeta 4 is 6. After analysis your n, you will get this way, or this equation of n1. Same with node number 2. Just to show you node number 2, so that will be zeta minus zeta 1, zeta minus zeta 3. I already neglect because it will be a 0, so no need to write zeta minus zeta 2, times zeta and minus zeta 4. For the node number 2, zeta 2 minus zeta 1, okay, I should start from the beginning and then continue zeta 2 minus zeta 3 and times zeta 2 minus zeta 4. Substitute the values of zeta and you will get the n of node number 2. Same for the node number 3 and for the node number 4. After that, check criteria. Check for shape function. The first one should, after substitute the values, you should get 1. and summation should be 1 for summation of all nodes. You should get 1, and actually you can go to previous videos. I explain and also I derive how I can do criteria or check criteria for all elements. You can go to previous videos. Actually I explain methods. I don't like to waste my time here because I have many, just to show you actually how I can work on Lagrange method. So let's go to second slide. Also here check criteria. Actually check criteria, we have 5 points or 5 checking, 5 or 4, actually I forget, I'm sorry. Actually you can do one by one, but here actually this is another solution from another guy. So let's continue. Here just derive for all all nodes, and you should get, and some summation you will get 0. The question D, here also I have 4 elements. Here elements number 1, elements number 2, element number 3, and element number 4. Okay, doesn't matter about the length, how much the length or the length of each element, doesn't matter. So actually because I'm working on Lagrange method, Lagrange method doesn't sorry, I'm very sorry, for goodness. Actually the value of zeta is depend on length, okay, but be careful with which is the original point. Here the original point is here on node number 3. On node number 3 is 0, so the right side will be positive and left side will be negative. Okay, so let's working on node number 1. Node number 1 start with 2 because I'm working on node number 1. Zeta minus zeta 2 times zeta minus zeta number 3 times zeta minus zeta 4 and times zeta minus zeta number 5. I have 5 nodes here in this element. Okay, so be careful. The nodes is the point that you start to the point that you end. So some students, they have confused between element and node. So if I have this line, I start from this node, okay, and I stopped in this node. This is x1 and x2. Okay, so this one I will call it element number 1 because I draw in one line. I draw from the x1 to the x2. But if I have, so this x1 is node number 1 and x2 is node number 2. If I have another element, this one I draw in any software, so I start from this point is x1 and I stopped in the x2 here, so this one is element number 1. If I want to continue, it doesn't matter if the same length of element 1 or doesn't matter. If I draw another element from this one, from point x2, I draw and I stopped here, so this one it will be equal x3. That means node number 3. So, and this one I call this one from this element or this line that I draw it from x2 to x3, I call element number 2, and so on. If I have also 2D elements, for example, in the software at any software cannot draw the whole element. If I want to draw for example square in the Abacus, in Ansys, or any software, it's not there's no anything to click on it and appear a square. If I want square, no, you should draw line by line in the software. So if I want to draw square or rectangle, but let's start with square,